Hey guys, my name is Luis Arellano. I'm the Senior Offering Manager for Data Science Experience. I see a few people, a few familiar faces, and a few other faces. I'm happy you guys made the time to come to my talk. So it's really good to be here. We actually announced the Data Science Experience last year at this exact event. It's been exactly 1 year now. And we went to production at the end of the year. And since then, we've been busy talking to customers, doing customer engagements. And through that experience, we've really kind of gotten a sense of what's going on in the industry and how enterprises are approaching their data science. And that's what we want to share with today. So first, the obligatory, there's nothing private, no information here. It's just regular information, so it's too fast. Second thing, I want just to do a little bit of introduction on ourselves. So the reason I want to put this up here is because we come from your side of the table. So we come from the client side. Armand, I'm the guy on the left without the beard. The guy on the right is my counterpart, Armand. He previously was a data scientist for Vodafone. So his job as a data scientist was on a day-to-day basis to readjust the antennas to reduce drop calls and everything. I was previously a VP of Analytics at Time Warner Cable for half the company, where I launched that function and built it from the ground up. So we've lived the day-to-day issues in actually building out practical data science applications. And we've brought that experience to bear in how we've designed and how we built the product. We've essentially built the product that we wish we had ourselves. That gave us a very particular mindset, a very particular point of view in what it was that we wanted to deliver. And in the course of doing that, we've actually been really surprised because when we took it out to market, our customers loved and responded to what we did, but then they actually wanted to take it in different directions that we hadn't anticipated. And we'll share some of those in a minute. So what is the IBM Data Science Experience? It's a platform that brings together everything a data scientist needs to be more productive, including tools, data, and content. So everything in one place, all integrated, ready to go. Essentially, it helps data scientists be a better data scientist. Sorry, this thing's getting a little wonky on me. It's built on a core open source stack. So we have Jupyter Notebooks, we have our Studio as tools, we have a big data engine, which is Apache Spark, which is why we're here, and then our default storage is object storage. So everything is kept open as much as possible. Around that core stack, we wrap in additional functionality to close the gaps. So things like the ability to sign on, to do a single sign-on, the ability to connect to enterprise data sources, all those things you need to make enterprise ready. That being said, the heart of the product, the heart of the platform, are really Jupyter Notebooks. And for those of you that aren't familiar with them, notebooks are rapidly becoming the de facto way to do data science. What they are, you can think of them as a Google Doc for analytics. So within the same document, you have your documentation, you have your lines of code, and then you have the output from that code. And that's in sharp contrast to what came before, which is all command line, terminal, where you couldn't really easily share or do anything. We also built in collaboration as a key part of what we do, what the DSX experience offers. So we offer that through shared workspaces. And these shared workspaces, you can think of them as a box. And in this box, you can put in all the artifacts. You can put in your notebooks, you can put in your data flows, your models. You can bring in your data and have it be resident there. You can connect to external data sources. You can connect to engines. So everything gets plugged into this one workspace. Then you can invite others to work. And when they show up to do work, they show up to an environment that's already pre-configured and running for them. So this is how we thought people would use this. So we thought that a data scientist would spend all day, day in, day out, working on their notebooks, working on projects. We were actually really surprised when clients started taking us in additional directions. What we intellectually understood but didn't really appreciate was how elegant a solution notebooks were for capturing and reusing data, knowledge. So with a notebook, because everything is documented in one place and captured in one place, and it's executable as well, it's actually a perfect medium for someone who's an expert to document what they know, and then take that and then pass that on to new people who are coming on board. So every company has people who have been there 10, 20 years, who have been doing the retention models, the churn models. Data science is not a new thing, right? So those guys are getting overwhelmed because it's one or two people, and now all of a sudden there's so many different initiatives. So there's a whole slew of people coming on board. But new people on board doesn't mean new capacity right away, it just means new people to train. So companies spotted this, and they immediately started using notebooks in new ways to capture and reuse that information. That gave rise to a few really interesting use cases. The first one is they actually wanted to build internal knowledge bases. So we had this feature, and we actually built this feature first for the community, where you could actually publish a notebook. So you create a notebook on your own. When you're ready, you publish it out to the world, so very much like a GitHub, or even like a Behance or something for data scientists. Companies saw that and said, we want that, but we want that internally. So companies have numerous practitioners within their teams. They have them in the risk department, the credit department, operations research, advanced analytics, IT, business intelligence. They have them all over the place. But these guys don't have a way to actually collaborate and share. So having a common platform, common tool enables them to do that. So we're seeing companies be really excited about this opportunity and start using this as a way to cross-pollinate. What's really interesting is that this actually becomes a way to build that institutional memory around analytics, right? Everything's right there, not in someone's head. And another subset of this is people are using it to document data sources. So the biggest problem that companies have isn't really the analytics, it's just getting a handle on your data. Just getting access to it, finding it, cleaning it. So typically what you do is you go put an entry in some catalog somewhere, and that entry says there's a table here, and the table represents this, and has these 5 fields, and 3 of them are dates, and 2 are numbers. But that's a start, but that's not enough. What this company is doing is they're actually taking, they're building a whole notebook around every single data source they have, and they're creating that rich record about how you actually use this data, what it represents and what it means. So the particular example here is a company that makes machinery, and they have sensors on that machinery. That sensor samples heat every minute. Well, is that at the beginning of the minute? At the end of the minute? Is it an average? Is it blended across the whole minute? Is there additional logic in there? So no one knows, right? Because this is pre-Internet of Things, pre-anyone thinking there's a lot of value in that data. So someone has to go back in and dig and understand all these different things, understand what's going on. But as they're doing that, they're actually capturing that in that notebook. So that notebook becomes that really detailed record of everything the company knows about that data source. So whenever that second guy comes in that needs that data, he just starts with that existing data set, copies the cells he needs, and drops that into his own place, right? So a huge productivity boost. Third example I'll mention is a company that's in our beta Watson machine learning program. So this is a company, it's an industrial engineering company. They actually produce factory lines of a certain type. So this factory line, at the end of it, has a huge fan that turns on to cool it. The logic right now is very simple. Is it hot? Yes, turn on. Does it stop being hot? Does it stop being hot? Then, turn off. The problem is there's many lines all around the world. The lines are similar in structure, but they're not identical. So they can't build a model that controls every single one. They can't build a single model that controls every single one. So what they're doing is they're actually handing it over to a senior data scientist, their top guy, who's going to build this master template for how to build models. He's going to build the master template, do it for one, then hand off to a smaller team, a central team in a lower cost location, much less experience around data science. And those guys are going to take that master template and they're going to create a custom model per these lines, right? So it's a way to get best of both. It's a way to capture that knowledge and actually create the models, but not where you need a very senior guy to do each one. I'll go into my favorite use case, which is how you actually get how you maximize the time of your most expert people. So this isn't the first time that there's been a talent shortage, right? You think of programmers here in Silicon Valley, or even before that, think of doctors. And you can actually look at how they've solved their problem as a template for us. And the way they've solved is what I call the operating room model. So in an operating room, so the challenge with specialists, right, medical specialists, that these guys are very senior. There's not enough of them. They spend their whole life learning how to do a certain thing. They go to conferences. They spend years apprenticing. So to maximize their time, what operating rooms do is they have someone who's very junior, the entry-level person, the nurse or the resident. They go prep the patient. They shave them, give them pills, draw on them. I'm not sure what else they do, but they do other things. And then they wheel them in. Once they wheel them in, then you bring a mid-level doctor, someone with some experience, but not the main guy. That guy does the first cuts, uses the weird tools to open them up, sucks up all the blood, does some simple operations, and then they bring in the main guy, and the head of surgery. So the head of surgery comes in, and he does the really hard stuff, right? The stuff that is delicate, the stuff that's specialized, the stuff that's really magic. He does his stuff, and then when he's done, puts his hands up and says, "Close up." And then the other two people sew the person back up, close everything up, and then wheel the patient away. Now, if that main guy had to do the whole thing himself, he can only do one or two. Because he can come in and just do the really hard part, the magic part, he can do probably 6 or 8. So that's how you actually maximize the scarce resource here, which is time from the most senior experts. And we've seen companies start to apply this in the way that they operate, because just like it's really hard to find a super talented head surgeon, it's really hard to find super experienced data science people. A lot of interest, people are still new to the field. So in that scenario, the business analyst is the entry-level person. They are close to the business. They go articulate the problem, understand what it is, bring the problem into the environment, create a project, create the notebook that documents what they're doing, bring in the data sources, right? Start putting in the plumbing. They can also do some of the very basic analysis and data cleansing, right? If age equals 300, obviously that's wrong. You don't need a rocket scientist for that. When they're done, they bring in the mid-level guy, the data scientist. That guy takes the next step at this. So he'll do the exploratory analysis, all the descriptive stats that really explain what's actually going on with this and give a sense of the data. They'll also do feature selection, right? So the correlation matrices to understand, to narrow down 100 features down to like 10 or so. And then they call in the big guy. And the big guy will then go pick the models, try different approaches, evaluate them, and then pick one, likewise saying, "I'm done." At which point the other two people close up. By closing up, that means taking that model and linking it to a data flow, a stream, even potentially a dashboard, so putting it to work somewhere. And this actually has a couple of benefits. So the first benefit, one, you maximize the time of the scarce resource, the expert data scientist. The second thing you're doing is you're actually leveraging a resource you couldn't leverage before. There are tons of business analysts within the company, but there's really no way to bring them on board and have them contribute. But if you approach it this way, they actually can. It doesn't take a rocket scientist to do very basic analysis, and someone needs to write up the documentation and needs to write up what it is that you're actually building, right? And someone has to be the liaison to the business side. By doing that, they can actually offload some of the load from the data science team so that the data science team can focus on the harder things that only they can do. So that's a huge benefit. And the third benefit, and probably the most important one, is it actually becomes an apprenticeship model. So in the course of doing your work, you're documenting what you're doing, you're capturing that knowledge. So the senior guy is doing that, the mid-level guy is doing that, the entry-level person is doing that. Well, each of them is actually learning from the others, right? So the mid-level guy is learning from the senior guy, seeing what he did, and learning literally through osmosis. Likewise, the business analyst is looking at what the mid-level guy did, at the feature selection and the descriptive, and learning what they did. After you've seen that 5 or 6 times, it's not hard to go out on your own, copy and paste, and do your own feature selection, right? So just in the course of ordinary, everyday work, you start building up this capability that kind of lifts the whole organization up organically. So we're super excited about this. We've seen this, we've seen several companies start trying this with a few projects just to get it off the ground. And it really just came from organic conversations with them. So switching a little bit over to use cases. So I want to talk a little bit more about, because we've been talking to many industries and many companies, we get a sense of what they're looking for, right? And kind of what we really think about, the way I think about this is, at the center of every industry, there's really a big, hairy core problem. And every company in that industry has that same big, hairy core problem. And if you can have an impact on that big, hairy core problem, even a tiny bit of an impact, that impact will cascade down to your bottom line and have a disproportionate impact there. So the example I always come to mind is payments. So if you can improve your fraud detection in payments, every incremental piece that you say there, that you improve there, falls to your profit line. Likewise, for example, on healthcare, the key big hairy problem there is, does this work? On insurance is, how likely is this person to do X? On transportation, we have these expensive trucks, things like, how can we actually match that better to demand? On marketing, how do we reach customers better? Who are they? On manufacturing, how do we ensure the line doesn't go down? On retail, it's how do we move the inventory to where it needs to be, right? On networks, how can we tell that someone's trying to penetrate it? On e-commerce, how can we recommend get more from that same person? In energy, likewise, a super expensive power plant, how can we better match that to capacity? So each of these are really the core big hairy problems at the heart of each of these industries. So that's what companies are attacking first. They're trying to see if they can use data science to make an impact on those issues. So I'll close just a call to action. Try it for yourself. We have a free offer, a free platform. You can go to datascience.ibm.com and try it for yourself. If you have your own platform in place, or you have something from someone else, use that. All you need is a way to capture the knowledge, so notebooks, and an environment that lets you share it, so collaboration services. It's still early days for many of these approaches, but we're optimistic. The other point I'll leave you guys with is we get asked a lot of these questions, and we start to see commonalities around what we get asked, what concerns people have. So we'll be writing a little bit more on our blog about organizational structures and how to acquire and develop talent. So that's it. That's all I have, guys. Thank you very much for your time.
Thank you, Luis, for sharing their learnings. So, any questions from the audience? Okay, I think it's time for lunch. Probably people are hungry. So, if you want to connect with after talk, just approach here. And thank you everyone for joining us.
Thanks, everyone.